Gas law stoichiometric questions. Solve the question, you need a balanced chemical equation. So this question says 55.8 ml of oxygen at STP. What volume of CO2 will produced when measured at STP? Okay, that is the one thing you need to be careful. STP condition. So STP is standard temperature and pressure, where we know that temperature will be 0 degrees Celsius or 273 Kelvin, or pressure will be any of those units from your formula sheet, like 1 atm, or which will be equal to 101.3 kPa, like that. So the condition at this STP condition, all gases, if they have 1 mole of particle, the volume will be equal to 22.4 liter. So you can use this conversion only if the question says STP. So at STP, all gases, 1 mole of all gases contains this much volume. Okay, so here this question says volume is given. So this is given 55.8 ml of oxygen, which is at STP. And you are looking for CO2 volume at STP. Okay, so let me process this. It says oxygen, given volume of oxygen is given, which is at STP condition. Okay, and you're looking for CO2, that is your unknown, and you're looking for the volume, which is also at STP condition. So that is the easiest type of question you are going to see. It's basically just stoichiometry. You are using this conversion. Okay, so you have to start a T-chart with the given. But there is a problem with the given. See, look at the volume. Volume is 55.8 ml. We can't use milliliter because our conversion is liters. So you are going to convert this into liters. We know that by dividing with 1,000. So basically you are moving this decimal 3 times, which is 0.05. 0.0558 liter. So you have to start from that value. So we'll start your T-chart stoichiometry from the given value in liter. That is the volume of oxygen. Then we know that since it is STP, 1 mole of oxygen will be 22.4 liter. Since it is liter here, you are going to write 22.4 liter of oxygen is 1 mole of oxygen. Okay. Now we are looking for CO2. Look at the equation. How many moles of oxygen is producing how many moles of CO2? That is a mole ratio. So we are going to write 3 mole of oxygen. That is a given, diagonally matching, and it will produce 2 mole of CO2. Okay. Then one more step, because we need liters. So I'm gonna write again, because it is at STP condition, 1 mole of CO2 is equal to 22.4 liters of CO2. Then you are going to calculate and write the answer. So when you calculate, you will get 0.0372 liters of CO2. So that is the first type of question. Second question, here it says oxygen 2.26 atm and 40 degrees Celsius. So here the given is oxygen, volume of oxygen, but which is not at STP condition. And you are looking for CO2 volume of CO2, that is your unknown, which is at STP condition. So this is a different type of problem because the given is not at STP, so you can't use the conversion 1 mole is equal to 22.4 because we already learned when temperature or pressure changes, volume will change. So this volume will not be equal to at this condition. So what you are going to do, the first step for this type of question, you are using ideal gas equation. To find the number of moles, you are going to find the number of moles, which is PV over RT. And P is given, which is 2.26 atm. And volume is given, that is 55.8 ml. But remember, you can't use milliliter because the value of the R is in liter. So you are going to convert this into liters, which is 0.0558 liters divided by, since pressure is in atm, you are going to use 0.821 liter atm mole Kelvin. Remember, volume must be in liter, pressure is in atm, and mole is always mole, and temperature is Kelvin. And here temperature is given 40 degrees Celsius. You have to convert that into Kelvin, so which is 330 Kelvin, which is 40 degrees Celsius plus 273. So now you have all the values. You will get the number of moles of oxygen, which is 0.00491 mole of oxygen. So now you have mole. Second step, use Stoich. So you are starting your T chart from this value, the moles of oxygen, which is 491 moles of oxygen. Then go to the equation. It says 3 mole of oxygen will produce 2 mole of CO2. And we can go further for the next step because the unknown is at STP condition. So you can say 1 mole of CO2 since it is at STP condition, which is 22.4 liters of CO2. We are done. So the answer is 0.0733 liters of CO2. Okay. Okay, that is the second type of question. So let us process what we learned. Okay. So the first type of gas Stoich question, the given is volume which is at STP, and unknown is also volume which is also at STP. So if it is STP to STP, you are using Stoich. Okay. Then second type of question, that's the one we just did. The given is volume but not at STP condition. But unknown is volume at STP. So for this type of question, there will be 2 steps. First, you are using PV equal to nRT equation to find N, which is moles of given. Then second step, use Stoich. Okay, let's see then third type of question. That's one we are going to do it. Okay, so this question, Again, volume is given, which is at STP. Okay, so we are going to write given is oxygen, volume of oxygen at STP. Okay, and we are going to find CO2. Again, volume of CO2, which is at a different temperature and pressure. So this is not at STP condition. Okay. So what we are going to do, since the first one is at STP, at the first step you are using Stoic. Okay. We will start from the volume, but remember it is in milliliter. 475 milliliter will be 0.475 liter. So you are starting from 0.475 liters of oxygen. Since it is at STP, we can say 1 mole is equal to 22.4 liters of oxygen. Okay. Now use the mole ratio from the equation. How many moles of oxygen there? Which is 3 moles of oxygen will produce 2 moles of CO2. But you cannot go further because this one is not at STP. So we are stopping here and you are calculating the number of moles there. So that is 0.141 moles of CO2. Okay. Then second step, we are using ideal gas equation and going to find volume, which is nRT divided by P. Okay, N is the one we are already got from this calculation, that is mole, and R, okay, we are going to see what is the unit of pressure. It is in atm, so R is 0.0821 liter atm mole Kelvin, and temperature, which is 57 degrees Celsius. You have to convert that into Kelvin by adding 273, which is 332 Kelvin, divided by pressure, which is given is 0.812 atm. So when you do the calculation, you will get volume of CO2. You just write VA. V is equal to 0.475 liters of CO2. Okay, that is a third type of question. That means this question, the given so volume, but that STP condition, okay, but unknown unknown is volume, which is not at STP condition. So what we did first, because the beginning is STP, you are using Stoic to find moles of unknown. Then use ideal gas equation to find volume of unknown. So that is the third type. Okay, now you can think about the fourth type. Given is volume which is not at STP condition. Okay, and the unknown is volume which is also not at STP. This will be the longest you will get. 3 steps. Okay, since it is not at STP, first step you are using PV equal to nRT to find moles of given. Second step, use Stoic to convert moles of given to unknown. Third step, use again ideal gas equation to find volume of unknown. That's it.